Hello guys and welcome to part 5. And in this part, we will use our Python scripts to create our iceberg tables via AWS Athena. Athena is a serverless function that allows you to do all kinds of query-related operations on your data. It also allows you to create metadata for the iceberg tables and much more. We also have other tools like Redshift, Lake Formation and EMR, but these will not be used for this tutorial as Athena and Glue will do for now. Let me give you guys a quick explanation about the scripts in front of me. We have iceberg migration, iceberg time travel as well as schema evolution. The iceberg migration script will call all the functions in Athena in order to create our iceberg tables. It does this by creating a database, plus some tables for each individual symbol. All of this is saved and created in Glue. Athena will not be able to find our data if it has no database to reference it to. In this context, this database simply points to our data in that training batch folder. It's not an actual database, you know what I mean? Next we have the schema evolution script. This script is exactly the same as the previous one, but the only difference here is that we added another column called spread. One may ask, why didn't you just add it on that other script instead of making two scripts? Let me tell you why. You see guys, when doing schema evolution, if you are to add a new column, this column will require new data moving forward. Meaning should we wish to go back and backfill the missing data, we will need to modify those existing Parquet files and that is tedious work. Also that snapshot version of that iceberg table will not be ready for use up until all the data has been filled. Technically you could use the previous snapshot, but it will not have this new column. Okay, let me run the scripts and show you what the output looks like. The first script has finished, and here in the logs we see all kind of stuff like data being filled in the tables and whatnot. The standard procedure basically. Now let me run the schema evolution script. This one will have the same output as the previous one, as the number of rows and files are technically the same. As for now, we shall wait it out. It will only take 1 minute max. This would be the perfect time for you to like the video, subscribe and comment if you guys have any questions you would like to ask. The script has finished running and as expected the output is identical. Now let us run the time travel script. This script will essentially allow us to view snapshots for each table, what kind of partition was applied, when were the last changes made, and also the ability to query a small portion of each snapshot. Pretty impressive if you ask me. Here we see all kinds of tables. We have the normal tables and the ones with the spread computed. The amount of tables will vary based on the number of symbols you have. If you have 20 symbols, you will likely have 40 tables in total if you decide to run both scripts. This script is super versatile. It literally simplifies all the basic iceberg table operations. If you guys can remember from my last video where we built a data lakehouse locally on our PC, this same script was used. The only difference is that I made some changes to it so it could run smoothly with Athena. This is one of the reasons why Athena makes life so much easier. Everything is super easy to set up, even a goldfish could do it. They have very small attention spans, but you get where I am going with this. We use the Glue data catalog. It's basically a super simple catalog that makes handling metadata easier. From my last project, I remember I had used a JDBC catalog, alongside a Postgres backend to create the tables. Me personally, That setup took 3 full weeks to configure. It was an awakening experience for real. Then you come over to AWS and realize it could be done in 4 days. That right there would show you that time spent on doing a task versus time spent making the task as easy as possible is two very different things. Just because you have driven a car for 20 years, that does not mean you can now drive a Formula One car. Especially in data, there is always a faster way to do the same task and with half the complications. Then I also experimented with Iceberg and man, it was a breeze. It literally did all the metadata handling in 20 minutes. I also have a repo for that, so feel free to check it out on GitHub. I will also leave a link. I believe that is the end of this part. In the next part we will configure our Trino and Spark engines and attempt to replicate this Athena setup.